Hello students, welcome in another lecture of your electrochemistry. So till now we discussed about the electrochemical series and I've told you that how the elements are arranged on the basis of their standard reduction values. And today we are going to discuss a very well known the standard reduction potential series where I am going to keep the elements in according to the values of their reduction potentials, standard reduction potentials, and we will see the applications of these values too. That means what type of questions they can ask you, and even you can make your own cell by selecting the any two elements from the given series. Okay, so now let's start with this chapter. So in this lecture, I have written the standard reduction potential series. Here I have started with the lithium, potassium, barium, strontium, calcium, sodium, magnesium, aluminium, and then manganese, zinc, chromium, iron, cobalt, nickel. After this the nickel will come, and then lead, because the long series, so I have skipped the elements, but I am going to tell you that chromium, after the chromium the iron will come, and then cobalt, and after the cobalt the nickel, and then lead, and after this hydrogen, copper, and your mercury, silver, gold, platinum, and then F, that means fluorine, right? So all of us knows that the standard reduction potential value for the hydrogen is your 0, right? So here you can see that the value of the standard reduction potential for the lithium is given as minus 3.05 volts. But as we move down in this series, we will see the value for the iron becomes as positive. That means when we will move down in standard reduction potential series, we will see that the values are going to increase. That means the tendency to gain the electron will increase, right? So that means they will become more and more strong reducing agent. All right. So now the thing is that how you will learn this series, that if we are going to make a cell, in that case you need to keep this thing in your mind, that which element will come above the hydrogen and the elements which will come down the hydrogens. So for this you can learn this series by taking the initials of all these elements, as I learned, like by taking the initials like Likba, Sarkana, Mag Al, Man, Jan, right? Crow, Fico, Nipub, and then hydrogen, and after that you can like high code aapka something like, so you can make your own like own technique to learn this series. You can take the first initial and you can mug up that series. Okay, so here you have seen that the elements are arranged according to their standard reduction potential values with respect to the hydrogen, and after the hydrogen normally the values are positive, right? Because till hydrogen they are negative, and for the hydrogen it is a 0 volt. Okay, so after this, what are the application of this standard reduction potential? Because we will see this thing in number of the cases, and even in our books and even different competitive exams, they will give you the values and ask you whether this cell will be spontaneous and this cell will exist or not. So we will see what the application of this series first. Okay. So what are the applications? So to find the spontaneity of a galvanic cell, whether it will be spontaneous or the not, as the value of the EMF should be greater than 0. So that means what? If we write the standard like E naught values of a cell, we will write it, as we know, we did a number of questions based on this concept, that the E naught of the cathode minus E naught of your anode. Alright. So here, if the question is, if this one is given, that means what? That means E naught of cathode should be higher than your E naught of your anode. Then only this value will be greater than 0. So it means what? It means the elements in this series, in standard reduction potential series, should be below the element which is present on the cathode, right? Should be placed below the anode. Then only this value will come as positive and you will get the positive value. That means the value which is greater than 0, and then only the cell will work. Okay. So if you are going to make a cell, in that case the element you will select from this series for the cathode, that should have the positive value. That means it should be placed below your anode. Anode should be above the cathode, and this is comparatively, that if you are selecting these two, that means this one should be your cathode. But if you are selecting these two, so it is a comparative value, right? That means anode should be above and cathode should be down it. below it. Alright, now here is a question for you. Suppose you have to make a cell of your copper and zinc. So now tell me that which element you will select as your anode and which element you will select as your cathode. So just check that E naught of your cell is equal to the E naught of cathode minus E naught of your anode. Okay. So that means the element from these two which will be present, which will act as a cathode, that should have the comparatively positive value than that of your anode. Okay. So here, just check the series copper. Where is copper? It is here. And where is your zinc? Zinc is here. So which one is below? Obviously copper is below. So that means copper, you need to take the copper as cathode. And as we know that I told you one word, lone, that means on the anode oxidation happens. Okay. So in this way, so you can keep in your mind and you can select the copper as a cathode and zinc as a anode. Then only the cell will work and it will be spontaneous. But if you take the zinc as your cathode and copper as the anode, then the cell will not work. Okay, it will not be spontaneous, I must say. So the next point is metals above the hydrogen in the series displace the hydrogen from the dilute mineral acid. So this thing we know from our lower classes too, but here the elements which are stronger than hydrogen, they can replace the hydrogen. That means elements should be present just above the hydrogen. So here if I take the zinc and treat it with some mineral acid, it will liberate the hydrogen. But if I select the copper I will treat the copper with any mineral acid, I will not get the hydrogen. Why? Because see, in this reaction, what is happening? The copper is going to oxidize. And normally oxidation happens on the anode. Alright? It happens on the anode. So that means for being on the anode, it should be above. Right? But here the copper is down the hydrogen. So that is why we cannot take it as anode. Alright, so this type of the reaction will not work. So this reaction will actually happen and this reaction will not work. So that is all about for this lecture for if now. So in our next lecture, I'll discuss with you another type of the cell and that is your electrolytic cell. So that is all about for your lecture. Stay safe. Thank you.